Okay, so this is page 36, using the net change theorem. And guys, all that the net change theorem says really is that a final value, if you're looking for a final value, that's going to be equal to an initial value plus the net change. Okay, and guys, you should write down those words if you don't think you're going to remember what these letters mean. Final value equals initial plus net change. Okay. And remember, guys, when you integrate a rate, that's when you get the net change. So to get a net change, you need to integrate a rate. Alrighty. Yeah, so basically this is, here it is right here. So a rate is the derivative in this context. All right, so consider the differentiable function f of t on the closed interval 4 to 5. Given the initial condition of this, use the net change theorem to express f of 5. Okay, so what this thing here is telling us is that this is our initial value, and this is our final value. So the final value is what you're looking for. Sometimes what you're looking for is at the beginning of the interval, but still you would call that the final value, because the interval could be going backwards. Okay. So the net change theorem says that our final value that we're looking for is equal to this initial value plus the integral. So now we've got to integrate a rate. So integrate, and then the interval would be from initial time to final time. Okay, and then we'll say dt. We'll do things with respect to time. So the x-axis is time, and the rate is f prime of t. Okay? Now, we know the initial value, so it's -1 plus the integral from 4 to 5 f prime of t dt. Okay. We'll do it another time. So consider the differentiable function g of t, this time on the interval -8 to 1. Given the initial condition, g of 1 is 7, so that's our initial value. Use the net change theorem. And the net change theorem just says that final value equals initial value plus net change. And this would be the final value. All right, so the final value is what we're looking for. G of 8 equals the initial value, g of 1, plus the integral from initial time to final time. Oopsie, the rate this time is g prime of t dt. So that is equal to 7 plus the integral from 1 to 8. Okay. All right, guys, the next one is very similar, so just a different letter. So let's move on to part B. So, guys, let's turn real quick in our packets to page 31. Okay. All right, page 31. So we're going to be using this information here. And yeah, sorry, I was thinking ahead. All right, page 31. So this has a bunch of information about velocity and acceleration and position. And down at the bottom here, guys, I just want to focus on this for a moment. So speeding up. A particle is going to be speeding up if its velocity and acceleration are either both positive or both negative. So another way of saying that is a particle is speeding up if its velocity and acceleration have the same sign. Another way of saying that, which we'll use actually in our explanation, is that the product of velocity and acceleration is positive. Okay, the product would have to be positive if they have the same sign. So this is another way that we can explain if a particle is speeding up. And then slowing down, would be if velocity and acceleration have opposite signs, but another way of verifying that would be to see if the velocity and acceleration product were negative. Okay, so we're going to use that. You should write this, guys, on page 31. Okay, and now we're on page 37. So we're going to find, oh, actually I should read the directions. For each problem below, you are given x of t or its instantaneous velocity function v of t. And guys, instantaneous, I will put that in parentheses because we don't have to write it. Or maybe we should just cross it off. That's redundant. Velocity is instantaneous velocity, or its velocity function v of t. X of t gives the position of a particle on the x-axis, where x of t is measured in feet and t is measured in seconds. In solving the problems, you may use Math 9 but not Math 8 unless otherwise specified. So Math 8, that means that derivatives we've got to do by hand, but integrals we still don't know how to do by hand, so we have to use Math 9. All right, guys, so, alrighty, so we need to find the velocity and acceleration functions. So we're going to find x of pi over 4, v of pi over 4, and a of pi over 4. So the position, velocity, and acceleration of a particle at time t equals pi over 4, which, by the way, is about like 0.785 seconds in this case. And maybe I'll just say, just to try to visualize more, note pi over 4 is approximately 0.785 seconds in this context. Alrighty, so for the first one, we just plug in pi over 4, but then we need the velocity and acceleration of this function. So first and second derivative. So let me rewrite this, guys. I've got to take the derivative, but I got to make sure that all of my terms are in a one-step derivative form. So notice the switch that I made, ax to the n, right there. Okay. So then the velocity function, v of t, is going to be x prime. So that's 5 cosine of t plus 1/2 t to the negative 1/2. Okay, so I just took the derivative of each of those. Now for the acceleration, I'm going to take the derivative of this. And so I'll just put that underneath. Acceleration. These are both one-step derivatives. So acceleration is the second derivative of position, but it is the first derivative of velocity. So you just take the derivative of velocity and you have acceleration. So negative 5, sine. Negative 5 sine of t minus 1/4 t to the negative 3/2. Okay, now guys, I'm about to plug in pi over 4 to all of these. And if you've got negative exponents or fractional exponents, convert to radical form because it will be easier to plug things in that way. So maybe underneath position, I'll just write, so v of t equals 5 cosine of t plus 1/2 radical t, okay? And we've got a of t equaling negative 5 sine of t minus 1/4 square root of t cubed. Okay. All right, guys, so we still have to plug in pi over 4 to all of these. And guys, I'm not gonna, well, no, maybe we'll get a decimal. Okay. So for x of t, or for x of pi over 4, x of pi over 4 equals 5 sine of pi over 4. And guys, try to go ahead of me if you can. Pi over 4, okay. Now the good thing about the AP test, guys, is that we don't have to, we do not need to simplify our answers. So like this would be a fine answer, I guess. No, maybe actually, I think we need to evaluate. We don't need to simplify, but we do need to evaluate functions. So like sine of pi over 4. Think of the pi over 4 circle. Sine would be the y-coordinate of that point. That's radical 2 over 2. So this ends up being 5 radical 2 over 2 plus the square root of pi over 4. Now, guys, all along the way, you have to be aware if this is a positive or a negative outcome. This is positive. This is a positive term. This is also a positive term. You're adding them. This is a positive value. So the position is positive, meaning that we are to the right of 0. However, let's just get a good handle on this. So 5, let's get a better handle on the position. So we know we're to the right of 0. That's a positive number. But 5 radical, oopsie. 5 radical 2 over 2 plus radical, okay. All right, let's say that this is 4.422, and the units here are feet. Okay, so here, this is where we are located on the number line, on the x-axis at this moment. Okay, now let's do v. All right, so now we need v of pi over 4. Okay, so it's going to be 5 times cosine of pi over 4, so that's also radical 2 over 2. And then that's 1 over 2 square root of pi over 4. Okay, now if we didn't have a calculator, then we would at least need to be able to tell whether this is a positive or a negative number. This is positive. This is also positive. So we're dealing with a positive outcome here on velocity, which would imply, so velocity, if velocity is positive, at this time, the particle is moving right. So its location is here, and it is moving right at about this many seconds. Okay, but let's actually get a decimal. All right, so that's, all right, so 5. And guys, any calculator stuff during a video, you really should be in a habit of doing it along with me, because you want your skills to be like sharp and fast. All right. Ah, okay. 4.0. We could just drop the 7. So I could just go 099. You don't have to round up. And this is feet per second. Okay, we won't do the second problem, guys. I'll stop after this. And then acceleration, I got to plug in pi over 4. When I plug pi over 4 in here, guys, I'm, again, for sine, getting radical 2 over 2. So acceleration at pi over 4 equals negative 5 radical 2 over 2 minus 1 over 4 square root of pi over 4 to the third. Okay, I'll get a decimal, but let's notice this is a negative term, and then this is another negative term. So we are taking a negative number, subtracting from it, actually a positive. Sorry, you're subtracting a positive. So this whole outcome is negative, which means on its own, acceleration being negative doesn't tell us much, but its product with velocity tells us whether the particle is speeding up or slowing down, okay? So let me actually get a decimal. So this time, -5, radical 2 divided by 2, minus 1 divided by 4, and then square root Yeah, and you could have used alpha y equals also for the fraction. Yeah, but guys, you should be following along and we should get that same number. And it is negative 5 feet per second squared. Okay, so we found all three of those things. And now we're going to answer, I kind of already talked about it, but we're going to answer B and C. At t equals pi over 4 seconds, is the particle traveling toward or away from the origin? Explain. Okay, so, all right, this is the explanation for B. So, sorry, I'll just do it down here. We're not going to do the second problem. So here's part B explanation. The answer, guys, is away. All right, and this is why. Away. All right, away. At t equals pi over 4, the particle is to the right of 0, traveling right. All right, and actually let me elaborate a little. This is because x of pi over 4 is greater than 0. So that means it's to the particle is located to the right of 0, and v of pi over 4 is positive, which according to our physics table on page 31 indicates the particle's moving right. Okay, right of 0, moving right, traveling away. All right, that was part B. Now part C. At t equals pi over 4 seconds, is the particle speeding up or slowing down? Explain. Okay, so this would be part C. This is the explanation. You could just cross this off, guys. I'll put that like on homework. All right, for part C, all right, the answer I'll tell you is slowing down. Slowing down. Alrighty, and then I'll say slowing down. V of pi over 4 is greater than 0. You'll see where this is going in a moment. And acceleration of pi over 4 is less than 0. So we'll do their I'm going to show their product. Or is less than 0. And then we could be like, therefore, the particle is slowing down. And guys, I think they may give you full credit. I would, but if you just mentioned this product is less than 0, like if you didn't say this, I would have seen your work above, and so I could see this logic here. But okay, there it is.